Alright guys, welcome to our first video notes. We're talking about the theory of plate tectonics today. So this is going to kind of bring together everything that we've been talking about over the past couple of days, explaining how Alfred Wegener had some pretty good points and how after his death it became known that we had seafloor spreading because of the mid-ocean ridge discovery, the mid-Atlantic ridge that we found. And that seafloor spreading was occurring, and because seafloor spreading was occurring, we knew that subduction was also occurring in a different location, creating those trenches. So let's bring this whole theory together. So the theory of plate tectonics is the most updated theory. It was updated in the 1960s. This explains how the Earth's crust is broken up into different pieces that we call these tectonic plates. So these plates are pretty random. They don't have a certain size. Some of them are pretty large, some are pretty small, and they don't fit any pattern to where their boundary lines are. They go right through the ocean. They can go right through continental crust. So it doesn't matter if it's the ocean or the continental land. It can be anywhere. And the plates move. So this theory explains that they move and that they affect each other because of that movement. So when when two plates are moving away from each other, that's going to cause other two plates to then collide or slide past each other. So this will all create different things because of this movement. And so this theory explains that the plates are in this very constant, slow motion. It's not fast, it's not random. It's every day it moves a little bit. So it doesn't start and stop, it doesn't go faster than sometimes slow. It's pretty constant, slow motion, and it's being driven by something called conduction currents that are happening in the mantle. We'll talk about that on the next slide. And so this constant slow motion is so slow that we compare it to the same rate that your fingernails grow, which is kind of silly. But your fingernails do not grow that fast, anywhere between 1 to 12 centimeters per year. So not much at all. So slow that you don't feel the plates are moving. They never go that fast where a person would actually be able to feel the movement, which is why it took us so long to make this discovery and update this theory. Okay, so let's talk about these convection currents. Convection currents are something that you experience all the time. You just don't know what it's called, and that's, in my opinion, the best kind of science. You're already an expert, you just didn't know it was a science thing. So let's talk about it. So first off, this is what causes the plates to move. It's occurring in the mantle. So in the lower part of the mantle, in that mesosphere, it's so close to the Earth's core, which is the heat source for our planet. It's no longer the sun. The sun only affects the lithosphere. Anything below the lithosphere is all going to be driven from heat that's happening in the core. The core is the heat source. So the material closer to the core will heat up the most. Now here's the trick with convection. Warmer things are naturally less dense, so they rise up. Becoming warmer makes it less dense and makes it naturally rise. Just like a hot air balloon, or in your house, the warmest part of your house is probably the attic space or whatever is the highest part of your house. But then as it rises up and it gets into the upper mantle in the asthenosphere, okay, as it rises up, it naturally cools off because it's getting farther away from the heat source. So it's cooling off, and cooler things become more dense and naturally sink down. Just like probably in your house, the coolest room is most likely your basement or your lowest level. And so we have a cycle now, because if the heat source is right here, the material warms up and it rises, gets farther away from the heat source, so it gets cool and it sinks down, where it warms back up and rises, and it cools off and it sinks down. So it's this cycle that's happening all throughout the mantle. So these convection cells are, several of them are circulating all around the globe. Very much like a boiling pot of water. If you've ever boiled rice or pasta noodles, look at it closer next time and you'll see them going in a circular pattern. That's the convection. So I have a picture that I'm going to have you draw. Let me see here. Okay. So add this into your notes. Okay. We have our plates. Moving past each other. Okay. Down here in the mantle, we're going to show the cycle that's happening, and we're going to label that the hot is rising and the cold is sinking. And so this is occurring because our core is right here, and it is radiating all this heat. So that's what's causing it to warm up. So if these plates are moving away from each other, then that means this plate will eventually collide into another plate. So you can imagine right here to be a subduction, where this plate is getting pulled down underneath. And then over here would just be, you can imagine, convections all throughout the mantle, creating this motion. Okay. Last up, getting ready for our lab tomorrow, I want you to add these definitions into your notebook over the 3 different types of plate boundaries. So we'll be demonstrating and reconstructing them tomorrow in our lab, our edible lab. So the first kind of boundary happens when the 2 plates are sliding past each other. So they're going past each other. There we go, past. That would be like this one here. Another type of boundary is the divergent boundary, where the plates are moving away from each other or diverging. That would be this one. And the last kind of boundary is the convergent boundary, where the plates are colliding, they're coming together or converging. And that would be like these here. So we'll talk about these in much more detail tomorrow. And that is it for your notes today. Thanks, guys.